Hello, everybody, and welcome to this evening's event. I'm Tara Garnett, and I'm Director of Table, and I'm a researcher at the University of Oxford. Just a bit of housekeeping, the event's being recorded, so I hope you're all happy with that. There will be an opportunity to ask questions of the panelists to try and answer as many as possible. Please, can you post your questions in the Q&A and not in the chat? So just to repeat, the Q&A, not in the chat. So yeah, this event is the first in a series that Table is organising in the run-up to COP27, and it's focusing, or the whole series is focusing on some of the key debates in and around livestock. So you can find more details of the other events that are coming up on the events page of the Table website, and there'll be a link to that in the chat. So the purpose of today is to explore the often heated question of the role of grazing livestock in the carbon cycle and the role of these animals in the context of their overall greenhouse gas emissions, the potential other uses for land and the greenhouse gas implications of that, our global climate mitigation and other environmental goals around biodiversity and so forth, and of course our food system challenges and priorities. So it's that whole entanglement of issues at which with the grazing animal as the sort of the epicenter of all the debates. I should also say that, there's been a lot of interest in the role and potential of grazing and grazing management. And the language and the discussion has moved on quite a lot, very rapidly in the last few years. There's this focus perhaps away from carbon specifically and towards the idea of regenerative grazing, which, as you all know, has a lot of other terms associated with it, such as adaptive multi-paddock grazing, holistic grazing, mob grazing, and so forth. And at its heart, ideas about regenerative grazing have ideas about experimentation, adaptation, learning, even learning from failure, with soils as the sort of the key to everything, including but not limited to carbon. So for many grazing practitioners, the whole sequestration thing might not be the primary goal at all, but part of sort of other broader personal, social, environmental goals. So I'm giving that context to say that, we are all interested in and familiar with this wider context, and we will actually at Table be producing a short briefing paper on regenerative agriculture. But at the same time, we also want to focus on carbon for this session, not because we want to take a highly reductive single issue approach, but because given obviously the urgency of the climate problem and the focus, the very clear focus for policymakers, I think we need to examine the role of grazing animals in greenhouse gas mitigation while recognizing this kind of broader set of ideas. So, and I know that this panel discussion today will end up ranging very widely. So I'm just going to hand over very soon to the panelists, but I just want to say that we want to be discussing three main topics today. So one is an overall picture of the land-based sector as a whole and its potential for climate mitigation, as well as how the science of soil carbon sequestration actually works. Then a more zooming in to look specifically at grazing animals and grasslands, and then to zoom out again and look at the role of ruminants within this broader set of sort of food security and climate challenges, and loads of other topics will fall out of that. So for now, I'm really pleased that Francesca Cotrufo, Pete Smith and Matthew Hyatt will be the panelists for today, and I'm going to ask each of them to introduce themselves because they can do it much better than I can. So can you each introduce yourselves very briefly, and then we'll get on to the main substance of the sort of 45 minutes odd discussion followed by questions. So how about you starting, Francesca?
Sure. Thanks so much, Tara, and thank you all for being here. I guess it's good evening, good morning, good afternoon from all over the world. I'm Francesca Cotorufo. I'm a professor at Colorado State University and also a founding member of the Soil Carbon Solutions Center here at CSU. I consider myself a soil ecologist and biogeochemist, and for the nearly 30 years of my career, I've studied the fundamental process, the foundational process that control the formation of soil organic carbon in soil and its persistence, as well as how it's modified by a number of changes and disturbances, but also more recently, how we can actually regenerate soil organic matter and soil carbon through management, both in grasslands, which occupy a large amount of my research program now, as well as croplands.
Great, thanks, Francesca. Pete, you're next on my screen.
Yeah, so I'm Pete Smith. I'm Professor of Soils and Global Change at the University of Aberdeen. My work has mostly focused around greenhouse gas emissions from the land sector, particularly agriculture. And that's led me to lead the IPCC, the Intergovernmental Panel on Climate Change, chapters on mitigation for the 4th and 5th assessment report. I did contribute also to the 6th assessment report, the chapter on agricultural mitigation, but my primary focus was in the cross-sectoral perspectives. So I've got a fairly, I take a global view. My research is all to do with quantifying the global potential for mitigation from different land management practices, what's good, what's bad, what's somewhere in between. And so that's what I'll be bringing to the table in this table debate.
Thanks, Pete. And Matthew, over to you. Matthew?
He appears to be frozen, Tara.
Ah, okay. Well, I'll ask Matthew to introduce himself when he comes back to life. So just to, yes, and a little introduction is in the chat. So let's go to the first question. And Pete, can I ask you to address this one with everyone else chipping in as and when they can? Can you give an overview of the land-based sector as its whole and its potential in the context of the overall climate picture and the overall greenhouse gas mitigation needs? So what are the land-based things you can do to draw carbon out the atmosphere? And also, can you give, because not everyone here is either a soil scientist or a soil ecologist, so can you give us a really ABC introduction to the science of soil carbon sequestration as well?
Yeah, sure, I'll try. Yeah. So the things you can do on the land. So the land is basically all land uses. So it covers grazing lands, it covers croplands, it covers peatlands and wetlands, everything you can do on land, forests. So all of these things can be manipulated. We manage these systems to a large extent. Most of the Earth's surface is managed. So we can do things to change how much carbon is stored in the ecosystems. So when we manage cropland, we can change our management practices on the soil to store more carbon in the soil. We can, of course, reduce our deforestation or plant trees to increase the carbon stocks in forest. And we can protect and restore peatlands. So we can protect intact peatlands, and we can also restore those that are degraded. So there's lots of different interventions we can make in all sectors of the land, by various actors such as farmers, foresters, other land managers, restoration, NGOs. All sorts of people can be actors to do something beneficial in the land sector. The potential in the land sector is an assessment by Bronson Griscom and colleagues in 2017. Thought it was calculated that it could offset up to about 20 to 30% of all greenhouse gas emissions that we emit on the planet if we add all of them up. And that's a technical potential, so that's maybe not realizable in reality, but that shows the sort of potential that we've got there. We emit about 50 gigatons of CO2 equivalents per year, and we could maybe offset around about 20 to 30% by interventions in the land sector. The way it works is Photosynthesis is the process by which carbon dioxide is taken out of the atmosphere. It's fixed by the plant, but through photosynthesis, and that's how the plant grows. It fixes CO2 from the atmosphere and converts that into sugars, which are then converted into protein, carbohydrates, and all the other things that make the plants grow. So when you plant a seedling in spring and you see it growing, all of that mass, about 50% of that mass, is made up of carbon, and all that carbon has come in from the atmosphere. It's not taken up from the soil or anywhere else. So that's the amazing thing about plants. They can take CO2 out of the atmosphere. Some of that CO2 is in the body of the plant. So if it's a long-lived plant like a tree, that stores a lot of carbon. As it grows, it stores more carbon. And until it reaches maturity, it's constantly, annually withdrawing CO2 from the atmosphere. I'm interested particularly in soils, and what happens in soils is part of that material from the plant, either in the roots, when the roots die and turn over, or through litter fall, for example, when trees shed their leaves in the autumn, in the fall, then some of that carbon can be retained in the soil. About 10 to 15% of the carbon that comes into the soil from the plant is stabilized in long-term forms. So that's what soil carbon sequestration is. 2 words of warning. It sounds too good to be true, doesn't it? And 2 words of warning that carbon sequestration has a couple of major limitations. Firstly, sink saturate. So as a tree reaches maturity, it gets to a position when it's in more or less equilibrium. So the carbon that it withdraws from the atmosphere is equal to the carbon that it respires out, because like us, plants respire. They respire out CO2 as well as taking it in. So that's in balance when trees and other plants reach equilibrium. And soils also reach an equilibrium. So if you've got a degraded soil and you improve your management practices, over time, that will eventually reach a saturation point. So it'll keep taking up CO2. That will gradually get less and less until it reaches a new equilibrium point. So that's sometimes called saturation. So that's one thing. The second caveat is that it's not permanent. So if you change your management practice, or if you chop down a tree, all those carbon sinks that you've built up can be lost in an instant. For example, in a wildfire, if you chop a tree down and burn it, or put it into pulp and paper where it turns over really quickly, you lose all of that carbon that you've stored. So it's not a substitute for fossil fuel emission reduction. That should be our primary focus. But whilst we're decarbonising all other sectors of society, the land-based sector can make an important contribution in the short term. I'll leave it there because the dogs are barking.
Thanks, Pete. Can I just ask for just a couple of points of clarification? So I was wondering if you could say, perhaps based on that 2017 study or any other studies, the balance of mitigation that is achievable by, let's say, not doing bad things like stopping deforestation or the conversion of grasslands to croplands versus doing actively good things. And then within that sort of active good things category, the balance between things like managing grasslands versus improving cropland management versus things like agroforestry or what have you.
Yeah, okay. So I'll take your first question first, which was, say again, I've forgotten as I preamble.
And the balance between not doing good things,
oh, yeah, that's right.
not doing bad things.
Yeah, that's right. Yeah. So a follow-up paper by Grazing et al. In 2020 looked at just the pantropics and looked at the impact of protecting forests and protecting peatlands versus what you could get from restoring them when they'd been degraded. And the potential was much better from protecting them. So that follows the old adage that it's much easier to not break something than it is to fix it after you've broken it. So protection should be the primary focus where we've got pristine systems, but where we have degraded them, for example, degraded forests where we've deforested areas or our degraded peatlands, there's a great potential to restore them. But it's not as great as the potential of just looking after what we've got. So that's the first thing. The second thing, in terms of carbon sequestration, soil carbon sequestration in particular, you can, because of that point I mentioned about saturation or reaching a new equilibrium, you can store more carbon in a cropland. There's more carbon sequestration potential, I should say, in a cropland than there is in a grassland, because the grasslands are already quite high in soil carbon, so there's not much room left to sequester more carbon. Whereas with a cropland, it may have lost between 40 and 60% of its original soil carbon. So that's a lot of potential to increase soil carbon. If you look at it like a bucket that's nearly full, by pouring water in the top, it just flows over the top of the bucket. You don't get any more in. But if the bucket is half empty, then you can fill it up by at least half as much again. So there's greater potential in croplands globally than there is in grazing lands. But if grazing lands have been significantly degraded, then there is potential to also increase the carbon in those. Great,
thanks, Pete. Francesca and Matthew, would you like to chip in? And Matthew, we lost you for a minute. I asked Pete and Francesca to introduce themselves. Perhaps when we get to your sort of the substantive question they asked you, if you formally introduce yourself there. But would either of you like to kind of chip in, add anything to what Pete said, challenge anything Pete said?
Yeah, no, certainly not challenging, but the saturation issue is a very critical point, as the persistence is. And I actually was typing in a response to one of the person. And so just to provide a little bit more insight into that, saturation refers to the amount of carbon in soil that is bonded to the minerals in soils. And so since the minerals are finite, there is a finite capacity to bond that kind of carbon. And in the context of climate change and carbon mitigation, that's the carbon that we have an interest in, because it's protected and turned over less, so its persistence is higher. However, we can always accumulate more carbon in free organic matter that can give us a buy time of a decadal time frame. But as Pete was saying, every carbon eventually will go back into the atmosphere. So this is one aspect that also changes as you go deeper in soil, because the deeper you go in soil, the less carbon there is, and therefore the more there is opportunity to put there more a new carbon and to bond it to minerals. And that's where the grasslands are interesting, because they have those deeper roots. Finally, one thing that is important about the change of management is critical also, as Pete was saying, that when we think about regenerative and do any change, that need to persist for a significant amount of time for the carbon to be sequestered. But maybe when we go more into the grasslands, I can refer to what Pete said and specifically address that for grasslands.
Thank you. Matthew, do you have anything else to add?
I think it's been already very well covered, so I'd be happy to move on, and maybe we can circle back around to some of these issues, but that was a great frame.
Okay, so Francesca, it's turning specifically to grasslands then. Can you go a bit more into detail about their role in soil carbon storage and sequestration, and the relationship between soil carbon sequestration, biodiversity where possible, and the role of grazing ruminants? So what are the overall impacts of grazing on soil carbon sequestration? Under what circumstances can there be gains, and under what circumstances losses?
Thanks, and thank you, Pete. You really made my life easier with all the background you provided. So why the grasslands are so important? I mean, one thing that if you think about the entire globe and you take out the poles, grasslands make up 40% of the land surfaces. So that's a lot of land, and just because of that, they are an interesting ecosystem. Again, going back to what Pete said about the different opportunity given by different ecosystems, the fact that grasslands are so extensive on land already make an important point. The other is that grassland vegetation store the majority of their carbon that they've taken from the atmosphere. 60% of that, they store it and they put it below below ground in roots and root exudates. And so they already push a lot of that carbon directly into the soil. And the other thing that connect to your issues about biodiversity, the grass is a natural prairie, is very, very highly biodiverse with legumes and forms and different type of grasses. Why is that important? First of all, because they fill all the niches of productivity, and so they can take more CO2 out of the atmosphere and do it for the longest period of the growing season. So they are highly productive in that respect. They push the carbon below ground, and also below ground, they fill all the niches with their roots, pumping a lot of that carbon right at depth, where, as we said before, there is more of the capacity to store carbon. Additionally, grasses support through their root system and through their carbon inputs and through their diversified carbon input that has a high proportion of nitrogen per any unit of carbon because they are not lignified. They support a very active and diverse food web. And the reason why that is important is because that 10 to 15, 20% of carbon that the plant put in that eventually stay in the soil is controlled by two things. Is the efficiency of transformation by the food web, as well as the capacity of the soil to store their carbon or minerals. And so it's the diversity of the inputs and the support a diverse food web, which is also more efficient at transforming that carbon and stabilize it throughout the soil profile to depth. Some grassland soils are meter and meter deep. So that's a lot of carbon that they can store. Now, coming to the rule of grazing. Natural grazing is a keystone element of grasslands. It's one of the things that maintain that biodiversity, that maintain that productivity year-round, that maintain the push of carbon down into the deep roots. And that's the role of all the wildlife herbivory. But the way in which they live in harmony with those environments and support biodiversity carbon stocks rather than decreasing it is because of their continuous movement on the land. And so they graze intensively for a short period of time. That means that they graze on the entire grasses without selecting, and that maintain the diversity. They also naturally fertilize with their droppings that are homogeneously laid on the ground, and that means that there are no patches of high urine inputs and therefore N2O emissions, but those are more uniformly added that can promote sequestration and food web efficiency rather than patches of greenhouse emissions. What have we done? We have impeded the movement of animal with fencing and with grazing, and we have forced animals, maybe less at any point in time, but to continuously stay. And also we graze animals that are much more fixed. They are not worried about predation, and that has changed the relationship between grazing and the grassland ecosystem and its sustainability. And actually, it's one of the reasons why grasslands worldwide are degraded. And the point I want to make is that this has created an opportunity. As Pete was saying before, the more degraded, the more potential there is to put back that carbon to raise the saturation. So the amount of carbon we can sequester in different grasslands is context dependent. It depends on how far they are from saturation, what the photosynthetic potential, what's the biodiversity of that site. But if we now change management and mimic the natural grazing and the potential they have, we can restore those grasslands, restore their ecosystem services and biodiversity, and sequester carbon. The point is that there will be livestock, but of course will be in much less numbers than what we graze today.
Thanks, Francesca. That was very, very clear. Just on your final points, the fact that the livestock numbers, that this approach will support be significantly less than today.
Sorry, I'm actually, as I said that, I wanted to make not per unit of grass. Actually, you can raise more animal and exploit more the entire rangelands if you do adaptive multi-paddock. But of course, if you take out the animals that are grazed on feed from croplands, then the numbers need to reduce.
Yeah.
So we can actually raise more animals sustainably on grasslands than today, but those will not make the number of the entire animals that are raised today in feedlot with feed from croplands.
Thanks for that clarification. I mean, does anyone want to chip in? I feel that Matthew this may also be something you'd like to reflect on in a bit. But I mean, could you just say a little bit about the sort of the specificity of context? I mean, you're based in Colorado. How does the kind of context there, differ from, East Africa or, the west of the UK? I mean, where the growing, the rearing, the grassland conditions are going to be very, very different.
So as Pete was saying, we can bring the ecosystem to what we expect could be a maximum capacity of stored carbon. So the first context is how far below that capacity they are. The second is how much carbon the plant in that system can take from the atmosphere, because at the end, to make that gap, you need to have carbon in. And so if we expect the carbon to come entirely from plant productivity, the context dependent is, of course, the climate and the productivity of that region. Then there is the specificity of the soil type and depth of that soil and the mineral capacity. We are doing a lot of studies that point to specific minerals that can sequester more carbon and so increase that capacity. So that is, and of course, every time you store carbon in soil, you need nitrogen and you need phosphorus. And so all those elements make up for the context. And of course, that's just for the biophysics. Then there is all the socioeconomics that expand that specificity and context dependency even more.
Great, thank you. Matthew, can we move on to you then? And I mean, firstly, introduce yourself, and secondly, we've sort of honed in on the grazing animals question, but perhaps you could say a little bit about how you see the role of ruminants more broadly, and the specifics of the goods and bads of different types of grazing management practice within the context of what you see to be our overall climate mitigation goals, as well as our food security priorities. So, I mean, how appropriate do you feel the intense focus on grazing management to be in the context of these wider challenges?
So, hi, I'm Matthew Hayek. I got cut off by our entire internet system here at NYU, just getting reset for about a minute and a half here. So kind of inopportune during my introduction, but here it is. I'm Matthew Hayek. I'm an assistant professor at New York University in the Department of Environmental Studies. We're a department that integrates across the natural, social sciences, and humanities. And this is kind of suited for my background, which was I did my PhD at Harvard in a group that measures greenhouse gases in the atmosphere from all sorts of sectors. I did my measurements above an old growth Amazon rainforest to study the ecological and biogeochemistry exchange of greenhouse gases between the Amazon forest and the overlying atmosphere. We could get a kind of a proxy of the entire system's photosynthesis and understand its vulnerability and resiliency to drought. While I was doing that research and researching global change in these forests to get a better idea of what might happen in 30 to 100 years' time with global climate change, was disappearing all across that greater region of the Amazon yesterday due to deforestation, predominantly for beef production. Throughout the Amazon, it's also for soy, which, as work from Table has shown, the vast majority of which goes towards animal feed as well as pressing for cooking and industrial oils. So the pivot towards food systems was then one that I made about 5 years ago. I kind of occupy a lot of the same areas that Pete was describing in his introduction, but approaching them from what I see as fresh angles, and there's never enough work to be done in this area. So I want to zoom way out and just talk about the role of food systems in global environmental change and in climate change. Food systems contribute 1/4 to 1/3 of global greenhouse gas emissions, depending on where you put the boundary around food systems and how much that boundary overlaps with things like fossil fuels. Of course, our food system uses a fair amount of fossil fuels for refrigeration, transport, energy processing. So is that manufacturing or energy or transportation, or is it food production? It's a little bit arbitrary. But generally, the consensus is 1/4 to 1/3 of greenhouse gas emissions. And non-fossil greenhouse gas emissions for non-fossil greenhouse gas emissions, food systems is by far the greatest emitter. So that would be non-fossil CO2 emissions from things like deforestation, as well as emissions of methane and nitrous oxide, which are the other greenhouse gases that are causing global warming. Agriculture is the largest source globally of both methane and nitrous oxide. Within that larger bucket, farming animals is the majority of those greenhouse gas emissions. It's something like 60%. And of those, cattle and other ruminants are the largest emitter of greenhouse gases, predominantly methane from their enteric fermentation, that is belches. It's fermentation to digest the cellulose of that grass that we can't eat into, edible things like fatty acids and protein and carbohydrates that those cattle can digest, which they've adopted through their ruminant digestive systems. So that enteric fermentation is a byproduct. It's an anoxic environment, low oxygen or anaerobic environment. So methane is the byproduct rather than CO2, which has oxygen in it. So ruminants are our largest source of methane, and methane in the atmosphere continues to increase. Methane specifically from ruminants in the atmosphere continues to increase. This has been the impetus to kind of tamp down overall livestock numbers, to kind of maybe flatten that curve of livestock methane production, and as well as potentially reverse it over time, whereas right now it's increasing. Just about every economic sector that is producing methane, from landfills to rice to oil and natural gas, is increasing. So we're in a state where we need to reverse the increase in greenhouse gas emissions for fossil CO2, as well as non-fossil greenhouse gas emissions. Deforestation is continuing. Enteric fermentation, methane is still rising. Nitrous oxide emissions from manure management and fertilizer are all still rising. So as I think Pete was discussing, preventing the expansion or the continued high rates of consumption are important. This can have a moderating effect on the amount of deforestation that's already occurring. But there are still areas of the world that don't have enough calories in them, don't have enough micronutrients, and ruminant agriculture, ruminant livestock can play a role in those environments, particularly low income tropical and subtropical developing countries. So there's a lot of meat that we consume in the globe. That amount is still rising. Only 1/4 in turn of that meat comes from ruminant agriculture, ruminant animals, ruminant livestock. But those ruminant livestock, because of their enteric fermentation, are responsible for the majority of the emissions, as well as the majority of global land use. Virtually all native grasslands, these areas that contain 40% of the world's carbon, virtually all native grasslands are occupied by ruminants in some way. But then also, and that I think is something on the order of like 20 million square kilometers. But then also we grow some edible feed crops for those livestock. And we also graze them in areas of pasture that were once forested. That would be a lot of land in the UK. That would be areas in the Brazilian Amazon and the Atlantic forests, sub-Saharan Africa, Eastern United States. These places would be forest were we not grazing livestock there. And that might sound kind of insane. Why would we disturb a native forest environment when we could grow land on pastures, native pastures in native grassland areas? And there are two reasons why we're not doing that. One of which I think is the less controversial reason. It is that a native forest biome has more sunlight and rainfall all year round. More NPP can be produced even in artificial pastures in an area of native forest than in an area of native grassland. And we can see it just by a satellite, how green these areas are and what fraction of the year they are green. The more controversial one would be that grasslands have already reached their maximum capacity of stocking density, offtake rates of that forage, et cetera, et cetera. That is, I don't know how well we know that. I think there's arguments, there are strong compelling reasons to believe that we may have overstocked and we're over harvesting grasslands by placing livestock on them in those native grassland areas. But some research out of Francesca's group and others say that maybe we could stock more if we were grazing those cattle in the right way. Those native, through AMP, through better management, through managing stocking densities and moving them around in the right way, et cetera. As far as I know, there is no literature to suggest that we could increase the output of those grasslands by 300%, which is what we would need to do to replace all of the cattle that we're currently raising in native forest areas. Native forest areas are only 20% of our overall grazing areas, but they're responsible for 60% of our beef production. So overall consumption of ruminant agriculture is too high if we want to be reforesting all of these areas. That being said, the areas that we may have to depopulate or increase the population of livestock in native forest area, I think is up to what I see as a very legitimate debate. So hopefully that has kind of brought us from a bird's eye view down into this area of the role of ruminants in native grassland areas. But it still overall requires certainly a reduction in meat consumption and almost certainly a large reduction in even just ruminant meat consumption, which in turn globally is only about a quarter of our meat consumption.
Thanks very much, Matthew. I mean, Francesca, would you like to kind of reflect upon that in any way? Or Pete? Well, some of those comments were directly to you, Francesca, so.
Yeah, I don't know. I mean, there was a lot again. I mean, we are now jumping, I guess, to what you wanted to have as the final conversation. We have now an opportunity to fully rethink about our food choices, our food system, how to produce the food. And as an ecologist, I can see that we should be guided by ecological processes and systems that scientifically we know well, and bring those principles in our anthropic system and food system. And so animals are important to maintain ecological processes. And actually, we are seeing the livestock integration in croplands is one of the better regenerative practice, in particularly for carbon sequestration. So do we have to live with no animals? I don't think so. As an ecologist, I think that animals are key to the ecosystem functioning and biodiversity of any croplands or grasslands or even forests for that matter. The question is the how we raise it, in which number we raise it, and therefore, and also locally. I mean, the context specific in my mind also come to maybe trying to have diets that make more sense for the land where you live in, and trying to avoid a lot of transportation of the food, but that is a minor topic. But for sure, the content, how can I say? I believe that again, livestock play a role in our diets, and play a key role in ecosystem functioning. But we'll need to reduce the amount of livestock we consume so that they can they don't require to be fed by intensive productivity on croplands, but they can be fed by residues of croplands that we don't use, that can be integrated into croplands, and of course they can raise in the grasslands. And there have been a lot of questions on why don't we go back to the natural grazers. I mean, ecologically that would be great, but that's a question for the social economics, and understand whether it's thinkable and acceptable by society to go back in that direction. As an ecologist, I would say that would be the best for rangelands. But I can see that has a lot of implication for the socioeconomics.
Just to clarify, by natural grazers, you mean wild herbivores, wild ungulates, and so forth.
Yeah, or even managed, but more like bisons rather than cattle here in the Great Plains.
Yeah. Pete, do you have any sort of comments on this question of sort of partly the sort of the native grasslands versus the sort of grasslands that were once forests, and also the difficulties of sort of categorizing and distinguishing, and also questions of kind of baseline? When does a forest become how far back do we go before we decide that something is kind of human generated versus natural? And then the sort of broader question of sort of cutting our dietary suit to fit this sort of environmental cloth, if you see what I mean. This idea that we are more sort of bioregionally determined in the way we eat.
Yeah, so the first question about the where grasslands belong. So a natural grassland is obviously preferable to have grasslands on steppe ecosystems than it has to have them on natural forest ecosystems. I quite agree with Matthew on that. I can see the economic drivers that drive that to not be the case, to deforest for grazing lands, but that's just done from a carbon cycle perspective, and it wrecks biodiversity, and it's unsustainable going forward. The same situation comes up when we talk about afforestation. We should only reforest areas that naturally support trees, rather than try to plant trees on areas that are naturally savannas, because they're bioclimatically more suitable to have grasslands. So it's a question of ecological suitability, as Francesca has said. That's been a key message of Francesca's all the way through. In terms of livestock consumption, diets, we know that there's an enormous mitigation potential there from changing what we eat. In over-consuming countries, Matthew made a great distinction between those countries that don't get enough calories and maybe even need to increase the number of livestock to support the population. But the majority of countries, and particularly developed countries, are over-consuming, and it's causing health problems with overconsumption of red meat and other products. So it would be better for human health and better for the health of the planet to reduce the amount of meat that we consume. It's unsustainable for biodiversity, it's unsustainable for the water cycle, it's unsustainable for greenhouse gas emissions. But that's not to say that in the context of this conversation, it's not an either-or situation. I think we will probably all agree that over-consuming countries need to reduce meat consumption, including ruminant product consumption and the number of ruminants we raise. But that doesn't necessarily mean that there are no ways of raising livestock in a more environmentally benign way. That's not to say you'll eliminate emissions, but given that there's going to be some meat in the mix, then that could maybe be that could maybe be raised in a more ecologically and environmentally friendly way.
Yeah, thanks, Pete. Just going back to your point, Francesca, about sort of eating diets that are more suited to what the local landscape can support and reducing food miles and all the rest of it. I mean, perhaps you could all think about this, is how does this sort of makes intuitive sense, but how does that fit from a sort of social justice perspective, bearing in mind that it may well be that the parts of the world that are quite affluent and that are already eating quite a lot of meat, you know, to they that have shall be given, whereas, and if you don't have some perhaps more globalized system of distribution, then you're getting, you know, you're getting rich people eating the meat because their land can support it. And so there isn't a right answer to this. I just wondered whether you could all have a think about that.
Allow me a joke. I love fish more than anything, and I was raised on the Mediterranean, and now I'm in the middle of Colorado, and I have to eat meat. Anyway, so I don't necessarily say it's affluence, but it's also, you know, where you are. And again, I don't pretend to be on top of all the numbers of how much food transport affect the entire greenhouse gas emission of the food sector, and that's where Matthew might say much. And so maybe if it's a smaller proportion, we can also not worry about that. But then the context specific, even if we then transport food across the globe, it's important that the regions that are best suited to produce that food are dedicated to that food production. And so again, I am in dryland, Colorado, where there is a lot of land that has been tilled and irrigated for a wheat fallow system for years, with salinization, with a lot of water consumption in a place that is getting drier and drier. Should that land be converted back to prairie and used to raise meat, whether it's buffalo or whether it's cow? I think so. I think that, you know, in drylands in particular, we should promote a conversion of irrigated agriculture, which is really unsustainable, to grassland production. In other area of the world, maybe not. Then maybe it's much better to maintain cropland production, but not to produce corn to feed animal, but to produce crops to feed the global population. And then let's think about package. I mean, if transportation is at the foundation of social injustice, let's think about how do we transport, how do we package so that the cost of that transportation is reduced, and we can enable more people to enjoy more diversified diet that are also better for their health.
Right. Matthew.
So yeah, just to chime in, just because that was a prompt from Francesca as well, to chime in about food transportation. Some estimates have put global food transportation at around 3%. And I think the boundaries of what counts as food transport were rather small. And another recent study put it up at 19% of our global food emissions were coming from transportation. But I think the boundaries of that were almost arbitrarily large. So they were counting the shipping of the things that ship the things that ship the things that produce our food, right? Raw chemicals, shipping raw chemicals that then go to ship fertilizers, et cetera, that then produce our food. The problem with that is that none of the other food system boundaries were quite as large. So it was a bit of a example of comparing apples to orange. The reason that I like that debate is that puts the goalposts as far as you possibly could, right? The maximum our food emissions from transport ever really could be is something like, 19%, or probably less if you were to put wider boundaries around the food system. So I think that there are certainly ways that we transport food that is, silly in terms of its efficiency. But I think generally, for reason that Francesca mentioned, the globalization of our food systems can be a force for good, even if we're not talking about neoliberal globalization, right? but some type of system that through planning or efficiency or markets moves areas that are resources from areas that are highly productive to large population centers in regions that would be far less productive can and should be a really good thing, right? Tomatoes grown in upstate New York have a higher greenhouse gas footprint because you need to power greenhouse gases than shipping those tomatoes all the way from Mexico. So when it comes to kind of ecology, I just want to remind ourselves that of two things. Using this kind of Colorado as a test bed for these kind of ecological principles, which I agree should always be adhered to. The first of which is that while grazing animals and maybe integrating them in crop production or getting rid of annualized production entirely may be a far more ecologically sound thing to do per acre, it is a far less efficient thing to do per calorie and might be a more environmentally impactful thing to do per calorie. Because for a given amount of area, grazing cattle or bison on a particular acre produces far less food than growing wheat, or even far less protein than growing wheat per acre. So that's a trade-off that has to be reckoned with, considering that food systems are indeed globalized. Wheat gets bundled into giant commodity packages in regions, continents, entire shipping, entire aggregation areas where they get bundled with other wheat that gets some type of market price. So if you produce less wheat, the price of wheat goes up. And this is what's happening with the blockages and war around Russia and Ukraine. There's less wheat, so prices are going up. And the people who can afford the least of that wheat are the first ones to not be able to pay it and have to starve. I'm not right now raising the specter of global insecurity for rewilding prairies, right? And in fact, some of our agricultural policy does very smart things by taking the most marginal land, the least productive potential croplands, and paying farmers to just rewild that. I think all around we can agree that's a very smart thing to do. But nonetheless, these trade-offs all exist. All land has opportunity costs with the amount of food that you can produce on it versus the amount of carbon that you can capture on it. The second point is that Colorado beef production is not inert even when it's on pastures. Colorado drylands don't have a year-long growing season, and much of the Colorado basin water is being sucked up to grow alfalfa that needs to feed these cattle when the climate is either too hot and dry or too cold and snowy for any or much grass to be able to grow. And really this alfalfa production that is plummeting the Colorado River basin, the water resources in the Colorado River basin, this alfalfa demand is the most responsible for that. And that in turn is going into beef and dairy production. And that may be the only reason why cattle population numbers are 2.5 million in Colorado, as opposed to something far lower than that. So just goes to show that the most ecologically sound thing to do, even in areas that are kind of more optimized for grazing and don't incur that much of an opportunity cost in that area, can potentially have impacts on the wider region on farms off of that place that you're referring to or thinking about.
If I can respond quickly to that, that's because we keep the animals here. That's where the migration of the animal is important, and not just the fencing of a small acreage of within a rangelands. That's where the idea that, and for sure, it seems like if we want to go back to something that is sustainable, it needs to be cooperative at large scale, where both in the cropland system or in the rangeland system, you let the region, if you want to cooperate. In particularly, like if you want to integrate livestock, you need to have the neighbor farmer that can bring the livestock into your operation or sell a variety of products, and so it's much larger, of course, as you were saying, Matt, than just saying we need to do this or we need to do that. And that's the to me the fascinating part is the integration of the socioeconomics and acceptance and with the biochemistry and ecology.
Thanks, Francesca. I'm aware that we have so many questions from the audience, and we're not possibly going to be able to get through them, but I think probably it's a good time to start. Some of them are sort of comments and reflections, and some of them are actually answers, and I'm not sure if you're going to have the answers to all of them, but there are several questions that say in variously different ways, if one were to, and I don't like the word go back to a system, I like perhaps moving forwards or into a system where we were going to be using livestock in a way or that is suited to the land base and that kind of coexists. If one were to do that, then what level of animal product consumption could such a system support? And I guess people want, I mean, they weren't necessarily giving figures. Some were giving figures for the UK, some were not specifying their location. So, I mean, I think perhaps what everyone has more or less hinted at is that it would be a lot less than we have today, perhaps less ruminant meat, but certainly a lot less overall meat. But if you have some numbers, then that would be very helpful and I think of interest.
Well, we've done one study, and it's one that Francesca may push back against heavily based on some of, and in part for good reason, based on for some of the things that we've talked about, which is that if we were to just remove feedlots and remove finishing cattle with grain at the end of their lives in the US, so this is US mainland specific, then depending on whether we used forages, that is, the alfalfa and hay that we're harvesting from viable croplands, or if we just use grasslands that cattle are on right now, we could produce respectively 61 or 27% of the beef that we're producing today. And this has to do with just how much biomass beef cattle consume that is not from any type of what we would consider a grassland, right? So I think this puts reasonable bounds on what that amount of beef would be, which is, about half or a quarter of the amount of beef that we're eating today. And that half, I think, is looking worse and worse for that reason that I mentioned, that we're essentially in a state of emergency with respect to all of the water that we're using to water alfalfa crops throughout the American West. But whether that lower number is indeed 27%, I think is kind of the subject of this debate in essence. And that's for the US. We're working on the similar analysis global, but the data is so much worse and the ecoregions are so much more vast that you have to onboard a lot more assumptions in order to make that analysis work quantitatively to any extent. But it was something like I was describing, that the amount of ruminant meat that we're producing from native grassland areas is something like only 40% of our total meat production, of our total beef rather, and ruminant meat production. And the amount that we're producing in native forest areas is something like 60%.
Sorry if you said I would push back. I totally agree with that. Like, I'm totally for a much more reduced meat intake and grow it sustainably on the land where it can grow. And so I certainly don't want that my vision in that is considered somebody that wants to push the cattle industry by any means. But I also don't want to say we don't have to consume any animal products because animals are bad. That's where I am. I'm sitting right now. We need to understand, and that's not my job, but we need to understand how many animals and in which way. Maybe more my job is in which way we can better integrate in the systems. And the other thing that I wanted to comment, you talk about the efficiency of calorie, but what about the energy that is consumed to produce those calories? That's another aspect. And again, I'm not an expert in that, but I think one that we need to consider. And so, yeah, I think we need to reduce in general and modify our diets so that they can be equitable and sustainable. But some amount of animal intake, it's not bad for the environment. That's my point.
Pete, you look like you're about to say something. Are you, or not specifically?
No, I was answering one of the questions in the Q&A by typing in, Tara.
Okay, thank you. There's another question which I think you all touched upon a little bit, which is about, we're talking about carbon, but what about, and sequestration, what about the nitrogen and the phosphorus that's needed to enable that process? And of course, that also gets to the question of the source of that nitrogen and that phosphorus. So, on the grounds that nothing can come from nothing, perhaps you can say a little bit about those interactions. Yeah, Pete, why don't you go ahead?
Yeah, I could. I think this is a bit of a red herring, because the reason it's come up is because all living things have a fixed sort of, or a ratio of carbon to nitrogen to phosphorus. The carbon to nitrogen, for example, it's about 10:1. So for every unit of carbon you've got in your body, you've got about every 10 units of carbon, you've got about 1 unit of nitrogen. So people have argued that to increase the soil carbon, then you'd also have to increase the nitrogen inputs and also the phosphorus inputs. But that's really ignoring the way the carbon gets there, because it gets there in organic matter. And the organic matter is from root exudates, or from leaves falling in, or from animal manure, or from compost. That already contains carbon and nitrogen and phosphorus. So you don't have to add additional nitrogen to it. People have done these calculations saying if you increase the global, the soil carbon by 1 gigaton, that's 0.1 gigaton of extra nitrogen you'd need, and you'd have to use the Haber-Bosch process, and it would cause this many emissions. That's nuts. That doesn't make any sense, because the nitrogen is going into the soil with the carbon. So it's a bit of a red herring.
And
Francesca, I can see you nodding.
Sorry, so just a naive question. What about the nitrogen you remove by simply eating the animal?
Oh, that's a good point. But that's the same with anything we eat, isn't it? When we eat wheat, that's been fertilized with nitrogen fertilizer. And when we eat that, unless we put that nitrogen back in, that's an argument for working towards a more circular economy. Nitrogen we can get from elsewhere, but phosphorus is really difficult to get. So I think there's a real case for utilizing better the nutrients that we excrete. Our human sewage, we don't put it on croplands generally, because it's polluted with all sorts of other things, industrial pollutants and organic phosphorus, because in Victorian times, in this country at least, we decided to put all of our sewage together, all the industrial waste and all the stuff that comes in from everywhere. If we kept the human sewage separate, we could get rid of the pathogens, and we could recycle that more effectively and use that to fertilize the soil. That would be the natural way of doing things. That's again, it comes back to Francesca's point about working with ecology and working with nature, mimicking what nature does. It's solved a lot of the problems for us.
Yeah, thanks. There's another question here, which is, it says, wild grazers here in Colorado migrated ranges spanning hundreds of miles. The movement allowed by grazing rotation is much smaller and involves a lot of fencing. So again, it goes back to something you already said. Why try to mimic the behavior of natural grazers when we could actually restore them? So, but this question of scale is very interesting. Perhaps you could comment.
Yeah, it's complicated. I mean, I'm seeing more and more managers of rangelands that move the cattle a lot from the upper mountains down to the valleys, and then has often, as Matthew was saying, they also have to supplement it for some period of the year. But again, it also depends on how many animal you have. You can also produce more forage and to support during the cold month a smaller herd. Yes, of course, it's complex, and again, it requires a rethinking, but the fencing is doable, and I've seen cowboys setting up fences in the middle of rangelands all the way up the mountains, and that's what's being done now to enable the movement. And one positive thing of that is that you actually exploit the productivity of the entire land. So cows would never walk all the way to the top of a mountain and graze under aspen if they weren't pushed up there. And so by forcing animals to move, you can exploit higher productivity, which means also having to produce less hay to supplement that food.
Thank you. Thank you. One thing we've talked a lot about, and of course we've gone much more broadly than simply a focus on carbon. So it's not only about the carbon, but it is also about the carbon. And we talk, there's lots of interesting work that the farmers are doing, but then we get to the question of monitoring, reporting, verification. So what are the problems and what are the possibilities there? Anyone able to say?
I don't know if Pete wants to start. I would say the problems are a lot. A lot of the tools have been designed for croplands, and actually, to my knowledge, and that's where maybe Pete will push back or will educate me. I don't believe that there are the type of modeling tools that represent the impact of different grazing management in the way in which they do for croplands. So there are some tools, they send ROTC or others, that represent grazing, but to be honest, they don't represent the real impact. It's very, very simplistic. And then there are other more or less more accounting methods. So there is a huge need, and that's why I'm excited about the work I'm doing, and Pete and others, on research to understand the mechanism and put that mechanism and those understanding into decision support tools. That's at the core of our research. I think worldwide there are many groups that are focusing on that, and I would expect that in 3-4 years we're going to have strong tools to predict the effect of different grazing management at scale, both for carbon sequestration and greenhouse gas emission. But right now we're not there. But again, the research is a lot in that area.
Yeah.
I think driving the science to produce more accurate and pragmatic tools is always incredibly important, which is, a lot of the work that Francesca does in this area reflects. I have huge worries about the kind of economy of all of this, however, and it's from my own experience working with ecosystem models, and that I didn't use models that were most suited for either crop production or native grasslands, but I worked with dynamic global vegetation models, specifically ones that were more designed to represent forests, because that was my ecosystem of interest. And what I know about these models is that there's thousands of parameters, including dozens that can be set just by the user before they start a model run. Every parameter needs to be set in reality, but there's a fair amount of knob tuning that is still a little bit more of art than science. And insofar as we need measurement, verification, validation, there will always be some type of third entity who is twisting those knobs. And my concern about almost all of these models is that they are over-determined. What that means is that you can change more parameters than there are necessarily measurement points to be making. And this idea that we can replace going out and measuring, doing thousands and millions of intensive measurements in the field of exactly how much carbon is accruing, because we can just use a model instead, ignores this over-determination problem. That for any company that's being incentivized in some way to produce a report saying, yes, you have this much carbon in your soils, therefore you will get some type of offset monetization for your farm production, is always going to fall prey to this problem of it just being really easy to, frankly, fudge the numbers. And that fudging can be done in a highly scientific way, because you have one output variable and millions of parameters that you can tweak still in a scientifically sound way.
Yeah, don't knock it, Matthew. I made a career out of it. So, but seriously, it's an important point. But and Francesca is developing. She's currently involved in developing a model that represents better grazing systems, and there's some that are going on around the world. Coming back to Matthew's point, though, those models are only as good as the data that drive them, the data that we put into them and that we parameterize them with, and that we test them against. And there's much better data on simple systems. When you're planting a wheat field, you've got all one type of plant, which you planted at a known density, and you know exactly when the operations are. You put on the fertilizer, you till it. So that makes those things intrinsically easier. It's still difficult, but it makes them easier to simulate them when you've got animals ranging all over them, depositing feces and other excreta. That makes it just necessarily more difficult. And as well as the complex interactions that those grazers have with the plants in the ecosystem. So hats off to you for trying, Francesca, and I hope that it's successful. But I think it's going to be difficult. It's going to be difficult because it's going to be constrained by the data, and we have to use the data as the primary source. We all agree on this. So Francesca, Matthew, and I all agree on this. The data has to be our primary thing, our real observations, and the model can only be used with confidence to project forward if we can show that it replicates all the systems all the situations that we challenge it with real data and real observations.
Thanks, Pete.
Of course, I couldn't agree more, as I am the person that has spent my life trying to understand system through experiment on the ground and collect the data. The good news in my mind is that now we are in, and will be even more, in a data-rich era. And so the real challenge we need to focus on understanding the main processes and controls that we need to represent in those models, so that they represent reality to the best of our knowledge and are structured in a way that are biophysically defined and the pools are measurable, and then create a data flow into those models so that the inputs are data rich for data that are collected even at the, with a high temporal and spatial frequency, what our sensor reach, remote sensing and other, world is going. And so if we can use the data that we have at high density and precision and accuracy, and using the correct processes, produce the output for the data that we still will, of course, need to verify, but at least we can verify with less granularity because it's harder to do, such as soil carbon. That to me is where we need to go. And we are not quite there yet, but I feel that with all the effort that worldwide is going into this, we will get there. That's my hope.
Great, thank you. There's a question here returning to issues of biodiversity, which goes like this. It says, if we're to return native forest grasslands to forest, i.e. in most of Western and Northern Europe, how do we get from A, which is 40 to 70% grasslands, to B, which is 90% forest? Do we currently value any of the environmental services, biodiversity and cultural services provided by some grasslands? And what's your take on the idea that the natural climax vegetation is not closed canopy forest, but wood pasture due to the presence of large herbivores? I mean, yes. Any comments? Pete?
Sorry, yeah, there will be sort of areas within an actual woodland glades which are created by ruminants, wild ruminants. So that's a fair point. That's the case in any sort of temperate forest. What was the other part of the question, Tara?
I think it was the how. It was how do we get there?
How? Yeah, well, I mean, the question would rather be is that where we want to get to? And I think most people would say that isn't where we want to get to. That we can't exist on a planet necessarily that just has all the natural climax vegetation, everything that would normally grow just grows there, and we live within that, because there's too many people on the planet for us to sustain all of that. We can sustain a lot more people on a lot less land, as Matthew has shown, and some of the work I've done has shown, if we ate less meat, because it's inefficient in terms of providing us with the calories and the protein and everything that we need. We can get most of that from plant material. It's cultural that we eat meat. That many of us eat meat anyway around the world, and we could do that on a lot less land, but we couldn't do it on no land. I think we couldn't sustain, 7.8 billion people we have on the planet. We couldn't sustain that all if we just allowed it all to go back to a sort of an avatar type situation, an avatar type world, just living in the forests. But Matthew would have a better say on this.
Well, and I don't have a definitive answer for this question, because what it should look like is just such a complex process of these, of these social processes. And, there's really heated debate happening in the media in the UK about what rewilding could and should look like. And
oh dear,
in the UK have entirely different ideas about what their cultural heritage even consists of. Was it rainforests? Was it, open canopies with wood bison in them? Was it nothing but sheep coast to coast? Depends on when you look in history and who was making those decisions, and hence who was going to make those decisions from here on out. But it's why I don't tend to kind of throw myself into the middle of debates, saying, no, by God, there should be, temperate forest with a closed canopy. It's more like what could happen. And I think the Northeastern United States provides an interesting case study in what could happen, as well as what harms what we might want to avoid if our food system goes in one of two different directions. So what has already happened in New England is that with the plowing of the Midwest and the Green Revolution and the ability to produce a lot of food in each acre there, the competitiveness of Northeastern agriculture shriveled up. We went from a condition in New England and upstate New York where it was 80 to 90% deforested. Most of that was low productivity hayfields, sheep, cattle, some corn silage, to the other direction, 80% forested in a lot of areas, 50 in some of the least forested areas like dairy country in Vermont and New York, upstate New York. And there were certainly terrible growing pains on the way there. A lot of farmers went bankrupt. Now we're in a situation where I imagine, I don't have a specific, and you got to control for a lot of the economics, but our forests generate a lot of economic activity. Hiking in the Whites and the Adirondacks in upstate New York, bed and breakfast, agro-tourism, etc. You can still have a lot of financial gains on lands that are closed canopy forest or some combination. Landscapes can provide a lot of economic benefit. It's not always the case. The best thing to do with that land is the best agriculture for that land, right? And I think this is important for the future directions that we're considering moving in. One of which is, making UK even more of a meat and dairy powerhouse, predominantly dairy. And the other one of which would be, eating far more fruits and vegetables, or going for next generation plant burgers, and that causing some of the UK landscape to shrivel up. The needs to extensively graze so much land. And I think the question, or we might be making a headache for ourselves, is by having arguments with one sheep farmer and saying, no, your land should look like this, and the sheep farmer saying, no, my land should look like that, as opposed to a much more macro scale question, which is, what amount of meat production is in line with our climate goals and our cultural values? What amount of meat consumption, rather, and what can we do for farmers to help them get out of that game if that amount of meat and dairy production isn't compatible with the food that we want? If, say, we have plant burgers and cell cultured meat, or are just eating more fruits and vegetables, we will need less land, and forests will come back into those areas, with a lot of scrubby vegetation going there first. But I think a question we can ask now is, as opposed to constraining options, what are more options that we can provide for people who are managing that land for their livelihoods? And what alternatives are there to extensive grazing, extensive and intensive crop production that might actually end up generating more financial value across fewer acres needing to be grazed?
Well, that links very well to a comment made by somebody, and I've just lost it. Here it is. She says, as a farmer, I don't want every bit of my diversified cattle and grain system, USA based, to rely on a subsidy, change of power in federal government. Suddenly I can't pay for investments I've made in better systems. I prefer a carbon market system, or maybe even a system that puts the environmental or ecosystem service value into the retail price of the finished product. If, and it's a big if, I get a higher price for it at market, and if consumers would be willing to pay for it. And this also links very well to what it appears to be is the most upvoted question that we've had, which is soil and climate scientists have been recommending meat reduction. Why is the message not working? What can be done to bring consumption trends into sanity? So we've had a discussion about the positive role that some level of grazing can play in the context of a substantial need to reduce our animal product consumption, and a facilitating environment that incentivizes farmers to do this. So how are you going to solve it? I think this is my question to you three. Solutions, please. Wisdom, at least. Pete.
I don't think it can be done by with a cudgel. I don't think we can force people to change, but we can provide incentives. There's some work that's been done at Oxford and some work that's been done at Cambridge has shown that just changing the way that you present food in the cafeteria can change people's behaviour. You put the meat at the end so that the plate is already filled up with salad and other things, other vegetables, before you get to the meat, and people take smaller portions of meat. So you're not really doing anything there. You're not beating people over the head. You're not telling them that they're bad for eating meat, but you can change the way that people think about it by so-called nudges in the way that you present it. And I think the public sector could do more. I've argued that the government should prioritise putting vegan and vegetarian meals in their public sector cafeterias to normalise it. At the moment, if you're a vegetarian or a vegan, you're regarded as the weirdo in the group. That's less so the case now than it used to be. And the meat eating is the social norm. I think those social norms could be changed a little bit, and I think particularly with the younger generation, that is changing rapidly. So I think those changing social norms will eventually work through, and people will consume less meat, if not for the planet, for their own health.
Thanks, Pete. Francesca, Matthew, do you have any more comments?
I don't know. I stopped hoping that by doing the right messaging and trying to explain rationally explain the reason why we should do something, people accept the rational reasons and embrace those changes, at least in high percentages. There is maybe 50%, I hope, of the population that do follow rationale and do listen and inform themselves and make decisions according to their needs and the needs of the planet. And but there is also a lot of disconnect, and so I do agree with Pete that a lot will need to come from broader, larger programs that take initiatives and do subsidies and drive a lot of those transformation, mostly from the economical standpoint so that people see it. The other thing that in a way gives me hope is that unfortunately we are at a point of crisis in terms of land farming and grazing, that the people that graze and farm, has the message you were reading before, are looking for solutions because they are at a moment in which it's not viable anymore to do what they've done before. And there is also generational change. So that's the other hope is that, in our university, we have modified and now we teach regenerative agriculture. And so that is another way where possibly some of this change is pushed. And then, to be honest, a lot of my research is funded by large corporations that before would have been totally against what I do, and now they seems to be at least wanting to change, and not just for greenwash, but to really modify their system. And so that's another way in which the change can happen faster.
Thanks, Francesca. Matthew, have you got, I'm aware we have 4 minutes left and I want to squeeze one more question in. So if you could be brief.
Yeah, just I think that Germany provides a pretty interesting case study in what meat reduction can consist of and policies that are consistent with that. And now that fewer young people in Germany are consuming less meat, it is actually driving down the meat consumption over the past decade in Germany by about 13%. And a lot of that is being offset by massive increases in plant meat substitutes. There's a common critique of these meat substitutes. Oh, that's just processed junk food and it just distracts people from eating whole plants. At the same time, vegetable and bean production consumption is up 10% and fruit consumption is up 23% in Germany. So they're actually kind of having their veggie burgers and eating their vegetables too, which is a really interesting example. Meanwhile, young people are far more likely to support policies that actually shift subsidies or taxes in the direction because they are already eating more sustainably. So it just completely undermines this other counter argument saying like, oh, personal decisions don't matter. It all should be systemic. When we actually make better decisions on a personal or institutional level, we're far more likely to support policies that are consistent with sustainability at a governance relevant level. So all positive examples. And lastly, yeah, okay, I'll just leave it there. One more question. Thanks.
I'm wondering if you could squash your reply into about half a minute each. I mean, there was one comment that came, which was, I perceived the literature on the potential of grazing systems as much more controversial than presented here. What are the main points of uncertainty in this discussion from your perspective, apart from stock density and management? So in your sort of final 30 seconds each before I close, where do you feel that there has been agreement within this, in this conversation? Where do you feel there is ongoing either disagreement or uncertainty or research priorities? Pete, how about you start?
I think it's mainly not a scientific question. I think the science has been misused by various lobbies to suggest like livestock aren't a problem because they sequester carbon in the soil. That's a mantra that I hear time and time again, to say because there are large carbon stocks in grassland, the carbon offsets any methane emissions. And that's simply not true. It's just mischaracterizing the science. So I think the science is pretty good. There are 1 or 2 papers out there that I disagree with, but that's always the case, which take a different slant on it. There's very little evidence that rotational grazing increases soil carbon. However, Francesca has published a paper. There's a lot of variability, but it just hints that there could be something there. So as a scientist, I'm led by the science. And if it turns out to be the case that this rotational grazing does increase soil carbon, I'll be happy to embrace that if that's what the evidence shows.
Thank you. Francesca, and then Matthew, very quickly.
I'm mostly interested in the context specific. So the variability of the response that Pete was saying is there. And we can't say rotational grazing increase soil carbon. Rotational grazing will increase soil carbon somewhere, but not somewhere else. And that's what we need to study.
Thank you. Matthew.
Agree. A lot of this is how we as a society debate what our values around food are, rather than actually a matter of the science being unsettled, which it is continuing to converge towards consensus and needing to improve both consumption and production. Where I think a lot of debates are still raging about what we want to do about our food systems is the role of consumption in supporting better production. And I would argue that more regenerative food consumption is a problem and going to be an obstacle in a globalized food system where commodities and different kind of things are bundled together in a way that we can't necessarily eat close to the source. I'm not arguing that we should be able to eat close to the source, but that as consumers, one of the best things we can do is decrease our overall meat consumption while the production end works on improving what a marginal amount of production is still left after and while we do that decreasing.
Right, well, that's it. I just want to thank our three panelists for all your really fascinating insights, and thank you, the audience. And also just to plug our next event, which is on the 28th, which is looking at debates around methane. So please do sign up for that if you're interested. So thanks very much to everyone, and have a good evening or day. Bye.